Remember I said that the product rule and the quotient rule would not follow intuitively from what we learned in the main limit theorem. It is not true that derivatives break up over multiplication or division. The product rule is different. So here it is. If f and g are differentiable functions, then the derivative of the product of f times g, let's call h of x, f of x times g of x. So h prime of x is going to be the derivative of the product of those two functions. That's what this notation means. The derivative of f times g with respect to x has 5 pieces. There's one, there's one, there's one, there's one, and there's one. The easiest way to learn the product rule and apply the product rule is to verbalize it. It's going to feel like we're back in 2nd grade doing silly stuff, but I have students that still, to this day, remember the product rule because we verbalized it this way. This is how I was taught the product rule when I was in college, and I still remember it. So we're going to call f of x function 1 and g of x function 2. When we verbalize, 1 means we write 1 down, our function that is 1, we write it down as they gave it to us. d2 means we are taking the derivative of 2. So that's going to be times g prime of x. Plus means obviously write the plus sign down. 2 means we are just going to write down our function that we chose as function 2 as they gave it to us times the derivative of function 1. So 1 d2 plus 2 d1. And if you'll look, that's exactly what we have here. 1 d2 plus 2 d1. That is the product rule for derivatives. That's how we're going to find derivatives of functions that are defined to be the products of two other functions. So let's work a couple of examples so that you can see this in action. Find f prime of x for f of x if f of x is the product of these two functions. We're going to call this function 1. We're going to call this function 2. So f prime of x is going to be 1, meaning I copy down the function as they gave it to me. d2, now I'm going to take the derivative of the second function. It is made up of power terms and a constant. So we know now that's 3x squared minus 3. The derivative of x is 1. The derivative of 1 is 0. So there's d2. So 1 d2 plus 2 means I'm going to write down the second function, the function I labeled as function 2, as they gave it to me, and then times d1, the derivative of that function. The derivative of x squared is 2x. The derivative of 17 is 0. There's f prime of x. I don't have to simplify. I don't have to distribute things out and gather like terms. This is correct. This is f prime of x. So if all they ask me to do is find the derivative of a product, of a function that is defined to be the product of two other functions, I'm done. In this one step, I have applied the product rule for derivatives, and I have found the correct derivative function. Now, they may ask me to go ahead and do something with this derivative. They may give me an x value and ask me to find the slope at that x value or the equation of the tangent line at that x value. At that point, I'll do more with this function. I would then clean it up and do some algebra on it. But if they just want the derivative function, I'm done. We never have to simplify. So let's go on to the second example here. Find f prime of x if f is this function times that function. So f prime of x Verbalizing is 1 d2 plus 2 d1. And I'm done. The first function as they gave it to me. The derivative of the second function. The second function as they gave it to me. And the derivative of the first function. Don't forget the plus. 1 d2 plus 2 d1. The product rule for derivatives. Let's work one final example. Suppose f and g are functions such that f of 5 is 4, f prime of 5 is 7, g of 5 is -3, and g prime of 5 is 2. What is the equation of the tangent line to the graph of h of x equals f of x times g of x at x equal 5? So, h of x is defined as the product of these two functions. They want me to find the equation of the tangent line. Remember, the slope of the tangent line is going to be the derivative of that function. So there's the point slope equation for a line. Given x1, y1, I need to find h prime and evaluate it at x1. They tell me that x equals 5. So there's my process. So h prime of x, I'm going to find my derivative in x first. Then I will plug in the specific x value that they want me to use. But our first step always is to find the derivative in the original independent variable, which is x for us. So using the product rule, it is 1 d2 plus 2 d1. Now I know that they want the derivative at the point of tangency. I know it's a point of tangency because I'm dealing with a tangent line. So now everywhere that there's an x, I'm going to write a 5 instead. I need f of 5 times g prime of 5 plus g of 5 times f prime of 5. That's why they gave me all this information to start with. I'm going to need that to find the slope of the tangent line at x equal 5. So let's plug those values in. F of 5, they tell me, is 4. G prime of 5 is 2. G of 5 is -3. And f prime of 5 is 7. So my slope is 8 minus 21. So my slope is -13. My point is 5. What? Well, I have a definition for h. It is f times g. And they gave me these two values so I can find what y is when x is 5. F of 5 is 4. G of 5 is -3. So my y coordinate to the point of tangency is -12. Now, the equation of the tangent line at x equal 5 is y minus -12 equals the slope of the tangent line times x minus 5. And I'm done. We're not going to worry about putting in the slope-intercept form. The point-slope form works just fine for us. So now we know the product rule for derivatives. Any function that is defined to be the product of two other functions, we can now find the derivative.